I'm gonna be the man who goes along with you. If I get drunk, well I know I'm gonna be the man who gets drunk next to you. And if I heaver, yeah I know I'm gonna be the man who's heavering to you. But I would walk 500 miles and I would walk 500 more just to be the man who walked 1,000 miles to fall down at your
1, 2, 3, 4.
All right, so we're going to get ready anytime soon. If you guys can make it to the seats, it'd be great.
Nice shirt, Artur.
All right. Welcome everybody, and thank you very much for being here this evening with us. This is the 11th Dublin Devops Meetup that we're running. We've been here with you guys for 2 years and a bit, 2 years and 3 months or so, and we're already some 1,700 members of this group. So the community is growing, and also I've learned, or I believe that we are the only DevOps meetup group that is running at the moment here in Ireland. I'm not sure if that's the case. Did you know if that's the case, that we just the only one? No? Okay, cool. No, in the country, because there used to be the Ireland DevOps group, and that's apparently they kind of stopped business, or they.
Well, it's the credit card of the owner expired. I paid for it just to not lose the group, and I sent a message saying, hey, like if you want it back, just let me know. I will transfer it back. But he didn't get back to me, so looks like he doesn't want the group back. But I tried.
Okay, good to know. Well, anyway, thank you very much for your collaboration, for your presence, of course. So this meetup is going to be finally recorded and streamed. It's being streamed live now. Hopefully, everybody will be happy with that. Yeah, we have like 7 viewers at the moment. It'll peak at 20 or 25 in some 10 minutes, or maybe more. So. Of course, just a reminder for everybody to tweet away. I mean, the hashtag that we're using is Devops Dublin. You can see that in the web portal and in the Meetup portal, and just tweet away, of course. So the agenda is where we want to go for now, Cassiano? Yeah. So the agenda for today, we have 4 speakers. So we'll take around 2 hours of meetup or so. So it's a half an hour per speaker typically. Some 20, 25 minutes talk plus 5 to 7 minutes questions. So initially we'll start with Christian Mahue, DevOps leader at Dun & Bradstreet, and he'll be talking about scaling our AWS environments for multiple teams. From there we'll have Guido Iaquinti, senior operations engineer at Slack, and he'll be talking about database systems at Slack, past, present, and future. And from there we have Cassiano Aquino. He's co-organizer of a Meetup, and he'll be talking about knowledge and experience. He's a senior staff engineer here in Zendesk.
Not in Nginx this time.
It's good for change. And finally, we have James Watson, who's coming from the UK. He works for Tomorrow International, and he'll be talking to us about Microsoft SQL Server 2017 on Linux. So
yeah, and by the way, next month, September, we have Nginx Conf in Portland. It's not here, yes. But if it happens that any of you in the United States, you want to participate, I got this code for us that give us like 50% of discount for anything on the website. Just use this code and register on this URL, and you'll be able to get 50% of discount. And I sent this also on my Twitter, so you'll be able to see anything. And by the way, I will be presenting. I got a slot there. They accepted me, so I will be presenting on Nginx Conf this year.
September in Portland, right?
Yes, it is.
Cool. All right, so what else do we have here? So just before going to that point, so of course, I think that most of the speakers are happy to be interrupted with questions, but also we can ask them at the end. They usually leave 5 to 7 minutes for that. So do you want to go to the code of conduct that we observe very strictly?
Tonight we need to pay attention to this.
You mean me or?
Yeah, no, because of the technology choices. Because we have the SQL server, so.
Okay. I'm sure that
we always do a joke, so yeah.
Cool. So our conference is dedicated to providing a harassment-free conference experience for everyone, regardless of gender, gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion or lack thereof, or technology choices. We do not tolerate harassment of conference participants in any form. Sexual language and imagery is not appropriate for any conference venue, including talks, workshops, parties, Twitter, and other online media. Conference participants violating these rules may be sanctioned or expelled from the conference without a refund at the discretion of the conference organizers. Thanks for the patience.
Yeah.
Cool. So just a few more things about the agenda. So normally what we'll do is we'll have a couple of talks and we'll go for a quick break of some 10 minutes or so, 10, 15 minutes, just to drink a beer or maybe go for some snacks. Then we'll go for the remainder 2 talks, and after that we'll be getting the pizza delivered like around 8:15 or so. Let me see. So we have the emergency exits are just through this door here, and then all the way back to the back of the building, actually. And then, of course, the main door over there, that's also an emergency exit. Bathrooms are just going out through the main door there, then the first door that you're going to find on your left in front of the elevators. Go ahead.
And all the things that we need to take.
Yeah.
He's kind of lost.
No, I have different points here.
Yeah, this is. Thank everyone for the presence, the presenters.
You can do that.
Yeah. So, like, again, I would like to thank everyone for the presence. We really appreciate everyone. This is, we try to do for the community. So, without the community, we don't exist. Thanks for all the presenters. Thank you, James, for coming and presenting to us. So, like, it's without the presenters. And also, if any of you have any topic that you would like to talk, would like to present, you are more than welcome to come here and present to us. And because there's more than anything else, it's made by the community for the community. So even if you don't have experience as a speaker or anything, like, let's do a lightning talk. We are here to help you. So, like, the idea is exactly this is for us to improve, to learn, and also for the speaker to improve, not just for the people that is listening. So it's a good opportunity for everyone.
Maybe just mentioning. Yeah, so that we have the next meetup is already kind of lined up partially. So we have 2 talks already lined up there, ready for that. That'll be in a couple of months. That'll be in early October. So please, if you're interested in presenting over there, send me an email. I guess that you have my, you have my meetup kind of a membership there group, so you can pick me there. And let's see if we can complete the typically 4 speakers as soon as possible. And now I think that without much further ado, we're gonna pass it over to Christian. He's gonna talk about AWS Dublin architecture and proposal. Thank you, Christian.
So hi, everyone. Thanks for coming out. So Dun & Bradstreet, it's a big company. Not sure if all of you are familiar with it. I sure wasn't before I started working there. But effectively, it's a company that sells data about companies to other companies. So it's not like a really hip startup or anything. It's not like a single web page that everyone can look at some really sweet graphics and animations on or anything. It's kind of like boring enterprisey stuff. And so because I'm a DevOps leader at this boring enterprisey company place, well, my problems are a little bit different than a lot of the stuff that we typically talk about in the DevOps world. So we don't just have a single app that was written to run on, say, AWS or Azure infrastructure, and thus we don't just utilize cloud stuff the way it was intended to be used, and it's all really easy, and then we can go do talks about how we made that really cool thing that's really easy to run. All of our stuff is kind of a bit different, where we have maybe a system that has like 20 or maybe even 30 years of legacy behind it. And we're trying to now keep that platform going in a modern environment. We're trying to move that to the cloud maybe. We have other stuff that we're trying to spin up in the cloud. And so what I would like to talk to you about a little bit today is kind of how we intend to manage that. Not all of this is completed or finished, but we're at least partway through this journey on virtually all of it. And I figured it was worth just chatting about what we're working on so far. So here's what we've got going on in Dublin so far. So going to discuss the typical stuff we do in DevOpsy world. So configuration management, AWS, Jenkins deployments, and so on. As was mentioned at the very beginning, please feel free to interrupt me at any point. This is probably like an hour's worth of stuff that I'm just going to brain dump on you all. So I'm going to go through it pretty quick. If there's something that sounds mildly interesting or greater, feel free to bring it up. All right, so configuration management, just to kick it off. So we use SaltStack for our configuration management system. And what's great about that is that it's an events-driven system where we can have a Salt minion that runs on a host, and we can have our Salt master out there. The Salt minion connects into the Salt master. In my world of horrible, horrible firewall rules, where we have tens of millions of firewall rules in various data centers around the world, this makes my life a lot easier than trying to reach out and touch everything. Anyway, from there, the Salt master can reach out and touch our infrastructure, and it does so based on things like EC2 tags or host names or IP or whatever else. So pretty typical configuration management story. On top of that, we then do all the stuff we're supposed to do for a host. And so this is a pitch that I might give at work for a team that has no involvement with configuration management until now, just to give them the basis of our expectation is that we will not have a human ever SSH into a host to modify anything. Nothing that gets modified manually. All right, so from that, we keep all the stuff we want to manage in a Git repo. So here we have, say, Apache 2.2. Our host is running Apache 2.2, let's say. We update our Git repo to say, now we're going to run Apache 2.4, and we push that out to all of our hosts. So cool. Git is authoritative. Whatever's there is what we get pushed out. I don't know, like none of you guys seem all that excited about this for some reason, but that's freaking amazing. Because I don't know if any of you have ever had to deal with an enterprise infrastructure where some people made that one machine that one time and another team had to run that one machine, and there's a little bit of documentation about what it's supposed to do, but none of it's really been updated in the last 6 years. And so taking a company and saying like, no, Git's authoritative is kind of a big deal. So yeah, you don't understand, but that one's huge. So moving on. So with this, Salt's event-driven. And so what that allows us to do is keep track of the SDLC for all of our services and all of the infrastructure that entails. So in this case, whenever we add a new machine into our environment, we can then add that machine to monitoring with all of the bits that make that machine, that needs to be monitored for that machine. So if that machine's running Apache or whatever, you monitor Apache. If it's running this one app, you monitor everything you can about the app. As with anything else in IT and DevOpsy stuff, monitor everything, because otherwise you don't know what you don't know. As part of that also, we can make sure that our inventory systems are up to date with CMDBs or whatever. And then the best part of this is that when I destroy that thing later, I can then tell my environment that that thing's been destroyed and the whole thing's cleaned up. So we're actually managing something. So when we kill off our EC2 auto-scaling instances, we have a couple hundred things that get destroyed. Those couple hundred things are being tracked for what's actually around in our environments in those awesome enterprise inventory systems that are perpetually out of date. All right. So the real meat and potatoes of all of this is AWS. So we have a bunch of teams. And we have a bunch of teams that want to get their job done. So that's pretty great. But I also want to make sure that I control costs on what those teams do. I need to make sure that I'm tracking what's going on, who's spinning up infrastructure. We have, I don't know, a couple hundred development teams or something, in which case there's just a lot of stuff to manage. So here's what we've been working on to kind of manage that and wrangle it a little bit. So for our AWS environments, we started off with a single account where we had some VPCs in it and some stuff in those VPCs. And that quickly got really unmaintainable, where that meant that we were always had to be perfect with every security group, every permission in S3, every IAM role that we ever assigned. Everything had to be perfect all the time, or we had a security problem because everyone's in a shared environment. And so what we ended up doing is creating accounts per application and per application environment. So in this case, we have ES microdev, some account that we have, but we also have a staging, and we also have a prod for that same for that same application. So this is one application, a dev account, a staging account, a prod account. So in that way, we can thus ensure that if you have access to the dev environment, you have access to the dev environment. You don't accidentally have access to a different environment because we screwed up something, and you don't accidentally have permission to, like, say, destroy something you're not supposed to destroy. You have the dev environment. So on top of that, we have a Git repo, and we have application code that lives in the Git repo, and that's all pretty normal and pretty standard, as you'd expect. But also in that Git repo, we keep our Terraform that provisions out that environment. So this is where we start to get into an actual good way of running things, as opposed to that one guy set up that infrastructure that one way, that one time. So the application code and the provisioning code live alongside each other in the same Git repo, and thus can be tracked as a cohesive whole as you move through this process. So that Terraform code that we have out there is responsible for ensuring that our instances are tagged appropriately and that we have the salt minion or whatever we need to do to manage that environment. The tags are actually really key to all of this, as that's how we track all of our costs and our billing stuff, as well as the provisioning itself. Anyway, that allows us to therefore take that kind of cookie cutter environment, hand that off to a dev team and say, great, here's your application code, do whatever you want. Here's a sample kind of hello world example of Terraform. You don't necessarily have to be an expert in everything Terraform or everything AWS, but this is a good starting place for you guys to be. And if you need any help, that's where our DevOps teams are around for. But in general, this is kind of our bootstrapping model. So from there, a development team can have their version 0.1 of app or whatever and iterate until they get to version 1.0 of app, and they don't have to call us, or we don't really have to care. They can kind of do what they need to do, and there's a little bit of oversight over what we're doing with Terraform to make sure it's not too crazy or anything. So with that, and that we have the salt minion or whatever we need to do to manage that environment. The tags are actually really key to all of this. Yep. As that's how we track all of our costs and our billing stuff, as well as the provisioning itself. Anyway, that allows us to therefore take that kind of cookie cutter environment, hand that off to a dev team, and say, great. So Terraform in this case provisions the AWS environment itself. So you want to create an EC2 instance, or you want to create a Beanstalk or something in AWS. Terraform is the thing we're using to do that operation. The why Terraform versus other stuff, because we've kind of used a little bit of everything up until this point, Terraform ended up being a pretty good way of getting us to scale our AWS bits. So there's CloudForm, to digress very briefly, CloudFormation's an API for you to operate in AWS. It's pretty good. It lets you generate some stuff. It's fine. But we ended up with, you had to kind of boilerplate a good chunk of stuff to make CloudFormation really useful. Where Terraform, it was a little bit easier for folks to write, and that's always advantageous, and that's nice. But the other bit is Terraform itself will call separate APIs than what CloudFormation calls. It's not a CloudFormation built product. It's using the EC2 API and so on, in which case it keeps its own state file. And that's potentially good or potentially bad, depending on how you looked at it. So initially, we didn't really like that because we now had this stuff operating in AWS. We had some EC2 instances, we had some subnets, we had some security groups and IAM policies and all. And we, in addition to that stuff actually existing, we had to keep a state file telling us that all that stuff exists. So if those things ever get out of sync, we kind of have problems. So we kind of viewed that as a bad thing. But as we went through this process, we now view that as kind of a helpful thing in that we can have a Terraform deployment process for our AWS environments themselves. So the thing that spun up that ES microservices dev environment there, the thing that made our VPC, well, our Terraform that provisioned that can provision our routes in there. It can provision the networks and the subnets. It can provision some IAM policies and so on. And it tells that it saves a lot of information in a state file. When the development team comes along and wants to just put their app in there, they don't really have to care about where their stuff lives and what VPC ID it's in or what subnet ID they're using. They can inherit that from the Terraform state file. So it ended up making it a little bit easier for us to be able to share all of those resources amongst the various roles that our various teams would have. The folks that make the environment can make the environment. The dev folks who want to use the environment, just use it. They don't have to be experts in the AWS ID scheme that we've created. And so having Terraform involved helped us out a little bit. So Terraform is used as kind of the bootstrapping layer for all of the infrastructure. Salt is what makes that infrastructure into a service. That help? It can provision our routes in there. It can provision the networks and the subnets. It can provision some IAM policies and so on. And it tells that the part of the orchestration is Terraform. Salt's also involved in the orchestration process. When you end up with something really complicated, like maybe a Hadoop cluster, you have to spin up part of cluster, you have to spin up another part of cluster, you have to tell the first part about the second part or whatever. There's a bunch of kind of hops around the orchestration, so we use Salt for that component as well. But we might spin up, I don't know, a couple hundred EC2 instances and then say, Salt, do your thing, and then it orchestrates that. But it's Terraform that makes the VMs. It's then Salt that makes them useful. The whole thing together is what we manage. The logic behind what happens in Salt, but the like accountability for what happens in Terraform. So we tag instances and we have a mandatory tag list that we require teams to use, and based on those tags is how Salt knows what to do with those things. So if a team says this is going to be at Apache whatever node, it's because they've tagged it at Apache whatever node that Salt then makes it the Apache whatever node. Sweet. All right, so from there, dev team makes their thing. Pretty great. They can then deploy that thing into staging. you guys aren't clapping there, but that again was freaking amazing, because I don't know if you ever had to deal with an enterprise environment where someone made that one piece of hardware that one time that was connected to that one switch behind that one firewall, and then you want to deploy it somewhere else and nothing works. So this again is an example of, because we manage the infrastructure next to the application code, we can deploy them in lockstep. Probably not anything groundbreaking, but for like a big enterprisey kind of a deployment, that actually kind of is groundbreaking, because there's literally teams and teams of people who are employed to manage this kind of thing. And I don't really want to manage stuff that I don't need people to manage. So whatever we've deployed into our dev environment that we validated or tested to say this is a 1.0 kind of product, when we're done with that testing lifecycle, we can then take what made that 1.0 product and deploy it into a new environment. In this case, our staging environment. As I mentioned a little bit ago, because we use those Terraform state files and all, it kind of just works. And there's not a whole lot we really have to change. The same Terraform code that deployed the dev can deploy staging and so on. And so we've gotten out of the problems of having to remediate environments. We're not trying to upgrade that one Linux CentOS 6 machine to be CentOS 7 to deploy that new thing so it can match the other environment. We're not dealing with any of that nonsense. You just deploy what you actually want. And so the thing that we now have in staging that we've deployed and we've called 1.0, we can then validate, run our QA tests or whatever and get sign off on. And that thing is what we run in production. So again, we have some assurance that the thing we're actually running is the thing that we've tested, which is the other thing that we've tested. So from there, this also allows our development team to then use the services that are available to them. So if a development team says, yeah, for my process, I kind of need something else, maybe I could use like SQS here and that'd be cool. Well, cool, just throw that into Terraform. We'll validate your Terraform at the PR stage, and that's where we cover kind of the separation of duties between various roles that you might have to have, where a developer can't just deploy whatever into the environment, and then that gets deployed in prod without anyone having a second pair of eyes on it. So at the PR stage is where we can then review our Terraform code to say, this is what's allowed or not, or this is a good idea or it's not, or you're doing this all crazy or whatever. And so again, instead of being in a pure ticket mode, we can then get into like a PR assistance mode. So anyway, development team decides that they're going to try out this SQS thing. They write their app around that. They test it out. They think this is really great or whatever. And again, we go through the same cycle of, great, now we deploy that thing. We don't have to remediate the old environment. We just deploy fresh and new. And now we can get on with our lives. Yeah.
Things like stakeholders in Dynamo where you actually verify provision.
Yep.
Where you transition from like staging to sorry, from dev to staging to prod and you keeping everything the same Terraform file.
Yep.
Do you use like Terraform variables or do you use Solid to kind of
We
sync?
have a lot of Terraform variables. Yep.
Because that basically kind of breaks what you said earlier when you said what you deployed in dev is the same in staging to prod because you actually have parameters that can actually change.
Right. So I guess I should qualify all of this with, it's not necessarily the same, it depends on your app. So if you're doing schema updates or something, you're obviously not going to just blow everything away and deploy fresh. You probably have some data resiliency that you need to keep around. So depends on the app, very much so. We do a bit of like blue-green deploys with our Dynamos, but the way we use Dynamo currently is it's kind of just a data storage layer. We don't really process Dynamo. It's just where we serve out of. So for us, it's actually not that big of a deal because we can just deploy the kind of versions data set that we want to run alongside the app, and so that part of it's fine for us. Yeah. We have a lot of Terraform variables.
So you were saying that the devs will make a change to Terraform code, and then that will go through a review process. At the far end of that, is it not the dev? Is it either an operations person
Right.
or some kind of automated process that actually applies that Terraform?
So we're going to get into what applies to Terraform right after this slide. But it can be the devs, it can be the DevOps team. If the devs don't really care to write the SQS bits for Terraform, they can always raise a ticket and say, hey, someone help me, I think this would be helpful or whatever. But what we want to make available is for the devs to do it, because otherwise we end up with a scalability issue of the one team becoming a blocker for anyone getting to do anything. So our goal with all of this is to build out enough infrastructure to be a foundational layer to enable all the teams to get their jobs done. This makes it sound like we're forcing all the teams to become experts on everything, and that's hopefully not the case, but we at least want to allow them to investigate if they want to. In some cases, maybe they, I don't know, see different performance scalability constraints than what they expected or something. And so if they look over the Terraform file and see that they're spinning up 4 instances and they want it to be 6, that's probably a PRable thing, even if you're not a Terraform wizard. Just changing the 4 to a 6, that kind of stuff. All right, so this is all controlled from Jenkins. So, in talking about how any of this gets deployed or how any of it gets managed, alongside in our Git repo, we had the application code, the Terraform. Well, we also have our Jenkins file that kind of manages what actually happens in our deployments and our whole process of management here. And so this is where we get into the separate account model being kind of the key to our security model for all of this. So in each of our accounts, we'll run an auto-scaled EC2 layer. And on that EC2 instance, we'll run ECS, that's Elastic Container Services, but effectively Docker. So on that, we'll run a Jenkins agent. And this is probably worth talking about in a little bit more detail, which is what the whole next group of stuff is all about. So, animation. This all came from a series of whiteboards, by the way, which is why it's all black and white boxes on a screen, because I got tired of drawing these things repeatedly throughout the day, constantly. Anyway, so as I mentioned, this whole thing's managed by the Jenkins file. And so as application code gets updated, it notifies our Jenkins server to say, do something, probably compile it or whatever you might want to do with your application code. So in this case, our Jenkins master reaches out to our environments. What's awesome about this setup is that the Jenkins master itself doesn't do anything itself. It has no executors on it. And then our Jenkins master itself has no ability to actually do anything in any of our environments except for activate the Jenkins agent. That's the ephemeral EC2 Docker image that lives in that environment. And so in this case, we have a Jenkins agent that has a build tool chain on it. So C++ or Java or whatever. So at that point, our Jenkins agent can then build the artifact, whatever it is. It can then copy that artifact to Nexus or Artifactory or wherever we're going to keep our stuff, and then it can die off. And so what's helpful about that is that we have a clean, pristine workspace every time. We're spinning up our build process through the same replicatable build process every time. So effectively trying to remove surprises from the whole build process. So, Jenkins, it's pretty good. That's fine. The next secret sauce of all of this comes to the deployment process. So our Jenkins master will go out and grab the Terraform code that we want to deploy. It'll then go off and spin up yet another Jenkins agent. Only this one, instead of having like a C++ or a Java build chain on it or whatever, this one has an IAM policy that allows it to act within that account and only that account. And so this is where we get into the segregation and separation of duties and our security resources, where what the Jenkins server is running right now is coming from that Jenkins file. That Jenkins file will explicitly call out what node that Jenkins job will run on. So if we say, run this Terraform on the ES microservices dev terraforming node, then that's where it's going to run, and that's the only place it can run. That the Jenkins agent itself is restricted to only that specific environment. The Jenkins master itself has no other access to any other environments, so we can't screw this up and accidentally deploy to dev or stage it or anything. I make this sound like we constantly deploy into production accidentally. I'm not aware of that being the case, but this also allows us to kind of scale our infrastructure a little bit better than having teams of people validate stuff. So anyway, our Jenkins agent there, which has the IAM policy, allows it to do stuff, can then grab our artifacts and then deploy some stuff into that environment, and great, now we have a thingy. The same process kind of occurs here for staging, where we have our Jenkins master, it goes out, it spins up the Jenkins agent, that Jenkins agent can grab the Terraform and the artifact and deploy a thingy. So staging and so on is going to be very similar to what we ran into before, only we don't have to build the artifact, so we only have the Terraform-ish agents that need to exist in those environments. All right, so because we're doing this stuff, I don't know, I think relatively sanely, that allows us to set up a proper deployment practice. This is where, again, we get into the app has to be written in such a way that allows this. But effectively, as we had an example here, we have a version 1.0 in our staging environment. We have a version 1.1 coming down the dev pipeline. And so we can deploy our version 1.1 into the environment and not screw up anything. From there, we can then validate that thing works. Then we can then cut over the DNS. We can keep the old environment around just to make sure in case we have any rollback or failover prospects. And then eventually you just kill it off. So, woo, blue-green deployments. That's, again, pretty amazing for a company that used to run data centers and run crap on hardware. The final bits of all of this come down to the other miscellaneous problems that we have in these environments. So secrets management kind of sucks all the time. So what we've been using is a thing called Vault. So Vault's also written by Hitachi Corp, the people that made Terraform, and The back end there says console cluster, and they also happen to make console. Anyway, quick intro to Vault. It's a REST API on some stuff. It doesn't really have a web interface by default in the open source version. You can pay for it in the enterprise version. We currently don't. So a client communicates this thing over HTTPS that talks to our ELB and our active passive Vault instance. Vault itself saves all of its data in an encrypted format. So it's not console that's encrypting this stuff. It's Vault itself is using console and saving only encrypted data there, in which case this whole thing's always encrypted when it goes over the wire. So yeah, Vault. If we think of the use case for any of this stuff, where we have maybe a Git repo that has a username and has some files in it, and those files need to access stuff, so they have usernames and passwords. I don't really want to have a username and password in the Git repo. That means anyone who has access to the Git repo has access to that thing that you are trying to secure, and then you also probably have some password history in there. So the whole thing's kind of bad. And so what we can do with Vault is I can save that username and or password into Vault, and then I have a token that allows me rights to be able to access that username and password that we saved in there. So that's pretty cool. We've now taken we've got our file that's in Git, and instead of having username and password, I have a call to Vault, and I have like this token, I guess, which means anyone who has access to my Git repo can read this file, and they can read the token, and then they can just run the call to Vault. So I haven't really solved my problem yet. And so on top of all of this, we're, again, using Salt. So the Salt environment is encrypted. So communication between the Salt master and the Salt minions is encrypted, and the Salt minions have to be validated through some scheme to be able to talk to our Salt master. So I can trade out that tokenized call to Vault and let Salt help me with that as well. So I can have my Salt minion here run this Vault read secret command, effectively saying, I want to do a thing in Vault. That causes my host to contact the Salt master, again, over this encrypted channel, and the Salt master knows who's talking to it. It's a validated host, not just anyone can do this operation. The Salt master knows what that host is. Again, it has the details of the AWS tags. It knows the IP address, the host name, and other bits of information about that host. And so it will make a call out to Vault itself and ask for a single-use token. It asks for a single-use token and passes along some of the information about that host that it uses to access the Vault policies. So that allows us to create a policy that says something like, all MySQL servers in this one dev environment can access a password, or just this one Jenkins server can access a password. Because Salt knows who the dev server, who the MySQL servers are in the dev environment, who the Jenkins server is, and so on. And so we can use that information to formulate our Vault policies. Anyway, Vault comes back with that single-use token, gives it to the Salt master gives it to our host, and the host goes off and makes a call to Vault. Since it's a single-use password, we know that no one else has done it, and this thing works or fails based on the policies that have been applied to it. And so we've traded our token management problem for the Salt management that we were using anyway. So effectively, we get passwordy stuff kind of for free using this scheme. I think that's pretty great. Relatedly, we have Jenkins involved in this process. And since we have all of our passwords in this whole Vault thing, I want to make sure that we're keeping stuff kind of authoritatively secure in one spot. And so again, we're using Vault. So if we have our Jenkins master out there, we have Salt that does the Jenkins install and installs the plugins or whatever. And one of the slick things about Jenkins is that it actually has like a initd-ish directory that it will read on startup and execute all the Groovy scripts that you have inside, which allows you to configure the bejesus out of Jenkins. And so in this process, we can copy over some Groovy scripts that we have templated, just like any other kind of configuration management templated thing, and we can pass those things over to Jenkins and say, do a Vault lookup here. At that point, our Jenkins master, using the same process that we looked at in the previous slide, can then go off to Vault, grab the various passwords that are necessary, and those passwords get saved into Jenkins as Jenkins credentials. And so this allows us to keep all of our passwords and secrets and stuff in Vault authoritatively. And so if we need to, I don't know, update our service accounts or whatever, we update them in Vault, and worst case scenario, we restart our Jenkins master. Since we're trying to recreate all of our Jenkins jobs and Jenkins pipelines, master restarts aren't the end of the world anymore. So that's the infrastructure we're looking at for Jenkins. And finally, well, nearly finally, the way we're doing some Salt stuff allows us to get out of the treadmill of the CMDB update process. So for all of you ITIL aficionados out there, The CMDB process keeps a pretty, hopefully, up-to-date inventory of your system. And the whole idea there is that you can, for any ticket problem that comes in, you have somebody to look up what's going on. So you have, I don't know, versions of things in your environments or the versions of your printers that you're attached to or whatever. But typically they really suck to keep up to date. And so what this allows us to do is have a salt master that lives in each environment. So let's say in Dublin here we have a salt master, Malibu they have one, and one of our teams in Short Hills, New Jersey has one, and so on. And so they manage their own infrastructure. And that's pretty great because then Dublin can't screw with Malibu and vice versa, as you'd expect. But we can also ask questions about our environments and use this stuff a little bit better. So what version of OpenSSL is being used in our environment, for example? We can run a top-level salt master over all of these things, have that top-level salt master have some rights to do stuff like ask that question. It can go off and run the OpenSSL package version-y thing. It can go off, ask for various salt masters, everything reports in, all the salt masters report in, and then we get our answer. So rather than having to keep our awesome CMDB up to date forever and used for really important stuff like vulnerability remediation, we can just ask the network hot because we kind of have that capability. All right. The other bit of this is that we can kind of share our environments a little bit. So we have some instructions, we have some variables, and so someone can run a salt master somewhere. They can configure their host to say, yep, we're going to run these 2 threads in Apache, we're going to turn off indexes or whatever. Then in Dublin, we want to override some of that stuff so we can use the same defaults as everyone else, but we can spin up our infrastructure, use the same Apache state, use the same defaults of turning off indexes, but then change some stuff around. So we can delegate authority to the lowest level team as necessary to effectively allow people to get their jobs done. The other really cool bit that I'm really excited about is this log aggregation thing. So enterprise log aggregation, we have a lot of data, saving a lot of data gets really expensive. We have policy requirements, all of it gets really complicated really fast. So what we've been working up is having AWS Kinesis used for our log aggregation. So that's a data stream where you just dump data into it and you pop it off the stack effectively. And so in our environments, we have some EC2. We have some stuff that lives in one of our data centers, in which case this one's Conway. So it's not AWS specific really, it's just the AWS service. So we run an agent on there. In our case, it's FluentD. We forward information, whatever it is, into a Kinesis stream. So that can be from log files, from syslog, from MySQL, whatever. So from Kinesis, we then have our custom consumer app. This is actually an EMR Spark cluster that pops data off. And with that, we can save all of that log information into an S3 bucket and have a 30-day retention interval. So cool, we have all of our logs saved, no problem. That's about as cheap as it's going to get because Kinesis charges you, I think it's 3 cents a gig, which when you're saving a ton of stuff, that really adds up after a while. So great, we have this S3 bucket. We also have a policy requirement which says that we'll save all audit data for 1 year. So, all right, our little consumer app can have that business logic in it, and we can save off all of our audit data into a Glacier bucket and have a 1-year retention interval. That's cool. So now we're completely done. That's awesome. Like we've solved our logging problem, except that this really sucks for humans. So we've got our policy stuff taken care of, but as a developer, how do you really like figure out what happened on your host yesterday? So for that, we also have our consumer app forward information to this Elasticsearch cluster where we run Kibana on it, and that gives us the human interface. But because we've already abstracted our policy requirements from the human requirements, that allows us to keep that Elasticsearch cluster really small. That only needs like, I don't know, 14 days or something worth of data to be really useful. So we don't need to have a really gigantic Elasticsearch cluster that saves data for a year, because that would get really pricey. Instead, we can outsource all that stuff to S3 and let the humans work on the data they actually need to work on. So logging, that's what we've got. And then the final bit of all of this is just to throw it all together. So in our various accounts, we've got our app, whatever it is. That's not my thing. So we have our auto-scaling EC2 instance. We have our ECS cluster that lives on top of that. And so we have our monitoring environments. In our case, we're using Zabbix. And so stuff in our environments has to send their monitoring data locally to their own VPC. So you don't have to worry about like weirdo firewalls or security group stuff and like popping holes in our firewalls various places. Stuff can just kind of send data locally. And then that one proxy can communicate with our server. That allows us to both scale it as well as keep our maintenance pretty low. Also on our ECS environments, we can run our own salt masters per environment. This allows us to keep things at the lowest level possible, meaning I can have a developer work, if they need to do work on the ES microservices dev environment, they can work on a salt master that only has access to the host within that environment, and that allows us to reduce the blast radius in event of typo or accidental mishap. If we need to, we can also operate at this higher level with that Dublin salt master, and so on. We've got the ephemeral Jenkins agents that I mentioned earlier that all tie into our Jenkins master. So that's a bit we discussed. We have the support infrastructure for our Kinesis logging thing that we've already mentioned. And because we run awesome split DNS between our various data centers and some domains that don't exist in real life, we also have our own DNS resolution stuff we need to run for our various internal crazy network issues. So that's pretty much it. That means that I have all that stuff running on an EC2 instance most of the time, like one EC2 instance most of the time, and thus it's reasonably affordable. It's also on an auto-scaling group, so that if we end up with environments where developers want to kick off a bazillion feature branches, our Jenkins environment can handle that because we can auto-scale those ECS backends and spin up more Jenkins agents as necessary. So effectively, the whole thing is kind of like self-scaling, and it kind of just works. So that's what I've got. Any questions? Shoot.
How does it work when you have multiple applications there, multiple environments? Because with years, there's always one app and it goes.
Yep.
But when you have 10 different environments all these environments managed, how do you do a deployment and ensure that
So you're never sure that everything's fine. So that comes down to having like rocking QA and unit tests and everything. But in our environments, what we tried to do to make that problem slightly easier was split up those applications to their own accounts. So you have a like API interface, you have an agreement of, I will respond this way. It's the same thing you would do with any microservice, although we're not necessarily microservicing this, but you have like an API contract that you would have with any of your downstream or upstream apps. And so you say, my app will respond this way to these calls, and you can deploy that, you can test that. So we can run that in its own AWS environment, and then anything else, merely we have to worry about like the security permissions roles to allow it to act. If it's a thing where we have like blue-green deployments, we can always fall back if there's a crappy deployment. But the management of all of this comes down to, I don't have multiple applications in the same AWS environment. I have multiple AWS environments, application each, which simplifies that slightly, but no matter what, it's still a crappy problem.
sorry, just when you do a blue-green deployments, you have a synchronization problem because you have to do a deployment and somebody needs
Yep. Well, you have their DNS TTL. So up until you do the deploy, you turn down your TTL and your DNS so that every service is checking constantly to see if it's the right name. And then you do your deployment, so everything's immediately talking to the new thing. And then you can raise your TTL back up so that everything kind of caches that name and is still talking to that same environment. Yeah.
So are you involved in test management of
It is. Yeah. So that was actually one that we did some research on, and it was a guy who had written that stuff and had it on a Git repo somewhere and hadn't contributed it back to the project. And so we pinged him and went like, hey, is this like ready to go? And he went, oh, whoops, we've been writing this thing for 2 years. I forgot all about it. Yeah, well, I'm doing it right now. So now it's an upstream salt and was just released. So it was only with this like most current release. That's totally there and not documented super great. Yeah, that's been there a while, it turns out. So with that, our Jenkins environments, we want to keep the Jenkins master as config managed as possible. So we say bind it to our Active Directory environment, for example. All of that config, we'll install the plugins from Salt, and then we have the Groovy configuration scripts that actually manage Jenkins and tell it to do all the stuff it's supposed to do. And so the goal there is that no humans really need to administer Jenkins. It's all run through Jenkins, the jobs are run through Jenkins files, and the administration of the machine itself is all from the configuration management side of things. So it goes through a Git-based workflow like anything else. Yeah.
Why are they at this
That's totally there and not documented super great. Have you ever been in a shop where everything was under control? Like I've been doing IT a long time, and I have a job for a reason. I've learned. Uh, Nothing's ever as easy as it should be for some reason. End up with a lot of cooks in the kitchen, and crazy decisions get made. There was some restriction once, and people made the best decisions they could in those environments. And now we look back on it and go, "What?" So we have. In my experience, it's always maintenance that kills you. So what we've been working on is a system to reduce that maintenance load as much as possible. We want to reduce surprises. We do deployments still. Every deployment's capable of being a headache unless you manage it properly. So this is just the deployment process we've been working on towards to be able to manage that stuff properly. We want to have development teams actually get their code out there with some velocity, but then control like their costs and all. With the separate account model, for example, no one has to come to me as the DevOps manager and to say, hey, that account yesterday had 82,000 in it, and today it's charging us 85K a month. What's up with that? I don't know. Why would I mean, ironically, I'm the guy who runs that environment or whatever, but I don't know why it's like that. I mean, some dev made a thing. I don't know. That's what we're supposed to do, right? So this is a model by which I can capture what makes that account, and keep all of the costs contained to that account, so that no one's asking me why our charges went from 82 to 85K, but they can instead say charges on this one account went from 5 to 8K, in which case we can then hand off that question to the engineering leader who manages the dev teams operating that environment to say, what's going on? And they can say, oh, we're still within our budget for these things. We had a feature branch to test this, and now we can get to a better answer a whole lot faster. All set? All right. Thanks so much, everyone.
Thank you, Chris. Everything set?
Yeah, I don't know why it's not full screen, but it's
All right.
here.
All right, now it's set. So thank you, Christian, for the presentation. Now we have Guido from Slack that will talk about database systems at Slack past, present, and future. Thank you.
So thank you very much. So welcome. My name is Guido. I'm working as an operation engineer here in Dublin, and I'm a member of the storage operation team. And before joining Slack, I didn't have any DBA experience. So today we're going to talk about like an overview about how we run database system at Slack. So what is Slack today and how we are running it. Then we're going to jump on the infrastructure and scalability changes that we are facing and what's the plan to solve them. And then we're going to conclude with Q&A. So you're all welcome to ask questions. Again, so let's start talking about what is Slack today. Today Slack, it's a platform that is used by several million of people. Again, more than 3.5 of these are connected simultaneously with one or more devices. And from an infrastructure perspective, this means that it's kind of a complex architecture that is pumping out tons of data every day. And again, we are talking about tens of billion requests, and we are pushing more than 90 gigabit per second from only the database layer at peak. And again, this is happening from hundreds of terabytes of data stored on hundreds of database servers. So Slack started just a few years ago as a pretty big LAMP stack, so Linux, Apache, MySQL, and PHP, that is now slowly getting upgraded. So we recently migrated PHP to HHVM, and we are also looking to kind of get rid of Apache very soon. So from a storage perspective, MySQL is the primary storage for all the customer data, and the setup didn't change much since the company started. And today we're going to talk about how we are running this MySQL. So we have a kind of in-house sharding topology that allows us to horizontally partition and scale the data set across multiple hosts. So let's now start talking about how everything works. So Slack runs on top of three primary MySQL clusters. The first is we call it Shard, and it's a cluster that virtually contains all the customer data that are tied to a specific team. So for example, messages, channels, DMs, etc. And its data is partitioned and scaled horizontally by team. So you have a team ID, most probably you're gonna end up on a single shard. On the other side, we have the mains. So main cluster is probably our most important cluster right now, and is a cluster that provides a mapping between the teams and the shards. So this means that to find the shard for a particular customer, we have to look up the team record in the main cluster. Again, this is an alternative way of consistent hashing. Use a table lookup. With that, we can have a kind of flexible, let's say, way to distribute user across several platforms. Then we also have a third cluster that we call Ox for all the things that are not tied to a specific team or that we don't think they are going to scale well in mains and shards. So how we're running all of this? So we run MySQL without using any PaaS, SaaS, whatever. We just use Amazon EC2 instances. And we are using it, we're using Amazon i2 instances, so that give us like very stable and high throughputs, like I/O performance, but unfortunately the storage is only ephemeral. So we don't use ABS. And we acknowledge the lack of availability of the ephemeral storage by providing and provisioning multiple masters across several AZ. We can also restore pretty quickly an instance from backup if needed. And so let's say with this consideration in mind, there is only a little risk of data loss if an AZ goes down or multiple AZ goes down. And minor notes that we are running the Percona MySQL fork. Right now we are still stuck on version 5.6. Okay, so now that's the interesting part. So we're running a master-master configuration. So each cluster, the cluster that we saw before, are deployed with one or more MySQL pairs. And each pair is configured as master-master using asynchronous replication. So that's something pretty unique. I think just other few companies in the world are doing that. And then we are explaining why. Probably not a lot of people are doing that anymore. But long story short, like each master is also the slave of the other master. And like this master-master topology, it's kind of designed to prefer availability over consistency that is very different than a typical like installation of MySQL. And again, this setup gives us some flexibility, but also like introduce few restrictions in our work. For example, like unique IDs like need to be generated by an external service, as we need to have primary keys that need to be unique across all the clusters. And also, like, as replication lag can be non-zero, we usually try to stick read and writes operation to one of the two pair. And we do that mostly by primary key. So for example, odd primary keys goes on side A or left side, even keys goes on side B or right side. And yeah, like last but not least, like when we write to one of the two sides, there can be some lag before it replicates to the other. So let's start now talking about how a write operation usually works. So starting from the application, like application is going to ask this unique ID service that we internally call ticketd for a unique ID. At this point, the application is going to use that key to write to one of the two master. Write is going to be then replicated to the other master via asynchronous replication. And in the case that the write doesn't go through, for example, the node is down, there is a network issue, whatever, the app automatically fail over to the other side. Read operation flow is easier as ticketd is not involved. So in this case, application can read from one of the two sides and fail over in case of issue. So let's now analyze the pros and cons of this architecture. So if a node goes down, like read and writes are automatically failover, so availability is not impacted. If a pair is running hot, we can scale it horizontally by splitting it with 2 or more new pairs. And like with this setup, like as it's asynchronous, like writes are gonna go as fast as the node can provide. Like I don't know if someone of you is familiar with synchronous replication, like Galera cluster, for example, where the performance of the cluster is as fast as the slowest node within the cluster. So due to that, let's say that replication lag can somehow be considered as a feature, because we can easily absorb a burst of write, for example, that they're going to just end up in replication lag on the other side. Again, like from an operator's perspective, we can also apply schema changes without impacting availability. Again, if our kind of small schema changes, we use the MySQL Online DDL functionality, and if our big schema change, we usually put offline one of the, let's say, two side, we perform the offline schema change, then we put it back online, and we flip them over. Again, everything is pretty cool, so like I think this allows us to quickly scale from 100 to million of customers. Why we are changing it? Because we are unfortunately also hitting some scalability issue. Again, with the current architecture, like we can partition a team across multiple shards because we use team ID as a sharding key. And also like resource usage is pretty low because our bottleneck is the SQL replication thread. Again, SQL replication thread right now, if you are not using a multi-threaded slave, that is pretty new feature, like is single-threaded, while MySQL master run, of course, multi-threaded. And also like there is no real value adding replicas to improve throughput. We also require statement-based replication. This is because like a limitation in our app, but again, that's a limitation especially for data warehouse and people that are dealing with the data coming from MySQL. And also like there is operational overhead when we, like from time to time, we have to manually resolve inconsistent entries between the clusters. So we know that we need to solve this problem, so let's start talking about how we're gonna do that. Again, the project, let's say when we start talking about it, like we say, okay, what we have to do and like what are kind of the requirements. So we would like to be able to shard in a more granular way than an entire team. So for example, there are things that are scaling well sharded by team, other things may be sharded by timestamp or by channel ID or by application ID, whatever. Second requirement is that, of course, we would like to don't disrupt too much the application code, and also like to decouple the infrastructure and the code. Another requirement that seems obvious, but that's anyway important, like we don't want to scale our infrastructure team linearly with the number of servers. That will be very expensive. And also, like we would like to be able to do maintenance without having any user visible downtime. So after a while, we decided to go for Vitess. So Vitess is an open source clustering technology that was built by YouTube, now Google, to horizontal scale the MySQL fleet. Again, it's built on top of MySQL replication and InnoDB, so two very battle-tested technology that we are extensively familiar with. And it uses sharding best practices like shared nothing and consistent hashing to operate. And also, like, it has been a core component of YouTube database infrastructure since 2011, and it's currently deployed on tens of thousands of MySQL instances. So I'm going to just give a kind of quick introduction about Vitess. Again, I'm not going to cover a lot of details because it will like require a completely dedicated talk. But let's say that Vitess uses several Go components to break down and archive all the requirements that we listed before. And the most important are the topology service, that is the metadata store that contains information about all the running server, the sharding scheme, and the replication graph. Then there is VT tablet, that is another Go component that sits on top of MySQL let's say, in front of MySQL and perform few tasks like maximize throughput, protect MySQL from harmful queries, manage connection pooling, query rewriting, query deduping, stuff like that. And also, like, let's say, one of the most important is the one that has to interact with the application is the components called VTGate. So VTGate is, again, like a Go component that's kind of a proxy server that routes the traffic to the correct VT tablet based on what is in the topology service and, of course, the query. And VTGate considers several things, again, like the sharding scheme, required latency for the query, availability of the tablets, and also of their underlying MySQL instances. So Vitess use the idea of key spaces, so where each key spaces can be considered as a partition of a whole database. So within the key space, then, we have a shard. So that's just a subset of record of the key space. So let's say that from an application perspective, like reading data from a key space, it's like reading from a MySQL database. However, a single query that is sent to Vitess can be routed to one or more shards, again, depending on where the request data is stored. And again, like everything that we mentioned, plus horizontal and vertical scaling, it's managed and handled by Vitess. And that's exactly what we were looking for. So again, like we started this, let's say, tour, I think, in February, more or less. So it was starting of Q1, and it's now August. So let's talk now about where we are in the deployment process. So I'm proud to say, and also a bit scared, that Vitess is currently running in production and it's powering a subset of Slack feature. So we're running a custom build that is built from an internal fork that is kind of in sync with the upstream from Google. And like we deploy each statelet components using autoscaling group that are managed by Terraform. And we also deploy all the stateful components running on EC2 i3 instances that are using the new volatile memory storage that is pretty fast. And when we deployed this new cluster, we also took the opportunity to upgrade MySQL, so to version 5.7. We also say, well, let's use global transaction ID. Let's introduce semi-synchronous replication. And also, why not, just to change more things, let's upgrade everything to 16.04. Let's upgrade the kernel, and so on. So cool, now that we talk about our current setup, let's talk about what we found so far. So we found that performance are pretty stable. Like median connection time is around 250, I think, microsec, while the query time is around 3 milliseconds. And why? Like, why it's so stable? Because if the key space is properly sharded and there aren't hotspots, we should only see network latency. So for each write, we should see 4 hops. So from the application to VTGate to VT tablets to another VT tablets due to semi-synchronous replication, plus 2 disk flashes on the 2 master. On the read operation, we just have 2 hops. So that's why, like, we have very stable performances. Unfortunately, we also found that it's a bit slower, but more stable than our current architecture. Again, why? Because of network latency. So as we were saying before, like with semi-synchronous replication, like each write has to be replicated cross availability zone before getting committed. And again, that's kind of something that we have to pay. Another very interesting thing, and I think that can be very interesting for any of you, like working with, let's say, deploying Vitess, we also found a lot of interesting things unrelated to Vitess. So first things that we found is that i3 instances are very fast, like are capable of more than 3.3 million IOPS with 4K blocks. And also like the new elastic network adapter that Amazon provides is pretty stable and like pretty nice. And also like i3 instances, like I don't know how they are making it, but like are not cheap. Again, like the account is not billed on my credit card, so I'm pretty happy about it. But are like very like cheaper. So like if you deploy, if you do a comparison between the i2 and i3s, like if you compare the storage that they give, the memory, and so on, you should get around 63% saving on average. And also, like, well, we also find few issues. So I think i3s are ready for prime time, but you should test them properly. So we found a data corruption issue under high load using Ubuntu. If XM ballooning is enabled, and also outplugging memory. Again, look at the bug, upgrade the kernel, but pay attention. And again, like for the next slide, I'm gonna wear Captain Obvious hat, because we found something very obvious, but also something very interesting. So again, I'm not sure about like if everyone knows the term availability zone. Again, Amazon defined them as an isolated location inside a region where each AZ is isolated, but the AZ in a region are connected through low latency link. The point is that, okay, let's consider each AZ as a data center or group of nearly located data center. If you do a connection cross AZ, you're gonna pay for it. And due to that, like we realized that if you can deploy, like in your application, a logic that can, let's say, pin or give some kind of affinity between service, between the same AZ, you're gonna get like a nice graph like that, where you can see that the latency is gonna go down. And again, that's just the latency of one of our backend services, pre and post change. So what's left? Like everything seems working. What we're working on, what I'm doing every day. So
Is lacking.
yeah, like the plan is to migrate more and more services to Vitesse. And also like kind of deploy tools like monitoring, infrastructure, and so on to make it easier for developers to use Vitesse. And of course, like to make our life easier, like build automation for cluster management. Like right now, kind of the build process is still kind of automation / manual and so on. So we're building libraries, we are building APIs, we are building stuff to make this happening automatically. And also, like, of course, like we're using an open source product, we're making improvements, let's say, within the company. We also would love and we are contributing back upstream. So that was my presentation. Thank you very much. Question? One.
You mentioned that there's some manual work to do in the beginning of the presentation. That was about when there's some consistency of data. Has that work gone away with Vitesse?
Yes. So let's say that manual operation that from time to time we have to, let's say, do or deal with, it's due to the master-master asynchronous system that we're running right now. So there are some very edge scenario where like a query goes through, like let's say it's replicated, but like if there is like a weird issue, like the web app could also commit and retry the same transaction, so using the same primary key, also on the other master. So when replication is gonna like go through and apply, you're gonna hit a primary key collision. So again, that's something that we are kind of improving and make it kind of more easy to handle with. But like I think once a month or once every 2 months, we have to deal with one of these issues. It's not again a big deal. It's something that you solve in 30 minutes, but we are a small team that is growing. We would like to have less interruption as possible.
Your availability zones and your shards. Do you have a policy on can you shard right across very freely?
Yes.
Shards arbitrarily.
Yeah. So we try to, let's say, splay master and replicas. Let's say each replicas is also the master, but let's say if you consider like left is the master, right is the replica, of course they cannot be on the same AZ, because if the AZ goes down, like customer can be impacted. On top of that, we try to, let's say, evenly distribute nodes across AZs, but let's say that is something that we don't kind of hard code yet. So it's a nice to have. From time to time, Amazon takes down an AZ. It happened 2 weeks ago, and we saw like tons of machine going down. It happened again. Like with our footprint, unfortunately, also if something small happen at the scale that we are, it's a big deal. Like it's not like again, like I cannot talk about numbers, but like we're talking about hundreds of machines like deployed on like AZs and so on. So
So at the end, you mentioned you wanted to improve the developer experience.
yeah.
So I guess, is there any Vitesse specific knowledge that's required for someone to code against this, or has it been like a difficult thing to train developers to do things?
Yeah, so for example, like finding the right sharding key, or like start a conversation with developer like, okay, you would like to use Vitesse, like what are your requirements? And also like how you would like to, let's say, set up your schema. Because again, you're gonna run, let's say, a MySQL schema on each tablet or on each MySQL, but plus you also need kind of a routing strategy that is called Vitesse schema or vSchema, where you can say, okay, I think this feature is gonna scale nicely if we shard by timestamp or if we shard by team ID and so on. Plus, unfortunately, not all the queries are allowed on Vitesse. So it's not 100% kind of MySQL compliant, let's say. So again, you might have to rewrite few queries, or also like, I don't know, PHP myadmin is not gonna work if you're using it, or I don't know, if you run an explain queries, instead of running on a single host, you have to write it on a like upper layer. So like kind of we're building this like tooling around it.
You said something about the maintenance scopes. So does the integrity scale because that's very important when you're working in teams.
Slow,
How do
you
you
mean?
maintain it? The communication is it going well together, or how does the data integrity is there? In a place? I mean,
Yeah, so data integrity is always, like, let's say it's handled by MySQL. So every time that you have a commit, you have a flash on disk, so the data is there, plus is replicated on another AZ. I don't know if I replied to your question or...
no, he says like it's very fast slow, right? But they say that the data is not slow. That's one of the problems with finding Vitesse.
Yeah, no, so the performance, I think. So I think we were talking about this, right? Right. So yeah, I didn't explain it well, but let's say the yellow line is our current architecture that, again, it's kind of more bumpy, but we have a query time that is around 1 point something millisecond, while Vitesse is 2 milliseconds, but it's pretty flat. And this is because of the network latency.
And I think that in the end, this should be good because when you do the average user experience without the queries, like the average maybe will be lower because of the spikes.
Yeah, like I think again, in general, like nothing is for free. Again, like the speed of the light is fast, but not that fast for like few workloads, let's say. Again, that's something I think that we can take. Like I think like a query time median of 2 milliseconds running thousand, hundreds of thousands of queries per second is something that I think we can take.
Just to make you know, if you make it fast, it's only for replication.
Yeah, so we're running semi-synchronous replication. So that means that every time that the master is gonna say, hey, okay, I have your rights, this means that it receives at least one acknowledge from a replica in another AZ. So if, for example, the master is gonna say, okay, I have your rights, and then, I don't know, something explodes in Virginia, like there's gonna be another host that has that information.
Expect it to come back if you have two more errors.
Yeah, so we are running multiple replicas across multiple SEs.
So that means that it's more fault tolerant
Yeah.
versus what you had before. So before you said started to do the thing.
Yes.
If your master failed, then you have the ability to actually lose it.
Yeah, that's the point. Like here is kind of more consistency. While in the current setup, we prefer availability over consistency. Can we go through?
I wasn't affected with
You mean for the backup? So backup, yeah, like it's a nice conversation because we're kind of thinking about changing how Vitesse makes backup. Right now, to make a backup, we currently do it on replicas. So what we do is shutting down a replica, let's say backing up InnoDB files and so on, pushing them on S3, and then start again the replica. At that point, it's going to connect to the master, take all the replication stream that, let's say, was kind of delayed. Yeah. So in the current architecture, we do online backup. So yeah, so in the current architecture is different. So current architecture we do online backup. So we don't lock MySQL. We kind of don't do anything. We just copy the file in a consistent way to S3. As I was saying, like with Vitesse, we currently shut down MySQL. We do the backup and then we restart it. And again, that's kind of, it's not a limitation, but like for us, for example, like we are running one more replica just for the backup. And from a business perspective, like we need to kind of justify this, let's say, more replica. And again, you have one replica for each shard. So if you have 100 shards, you're going to have 100 replica more just to take a backup. So right now we are thinking at least to experiment for an online backup strategy for Vitesse.
Question is, you guys are using only Vitesse MySQL as your data storage?
Let's say Vitesse is, we're currently deploying it. So right now it's just powering, let's say, 1% of Slack. In the future, we hope to bump this number higher and higher until if we find that, let's say, everything is okay and it's not anymore kind of an experiment, like all Slack is probably going to run on Vitesse. But right now, let's say only 1% is running on it.
You have Vitesse, 1%, MySQL?
No, 99% the MySQL infrastructure that you saw before. 1% this MySQL infrastructure.
You don't use Elasticsearch, Cassandra?
No, so the single, let's say, the source of truth, it's always MySQL. Then we use Elasticsearch, we use tons of other stuff. But let's say, to understand if, I don't know, every time that you type a message and you press enter, that message goes to MySQL. You put a reaction on a message that a friend wrote, it goes to MySQL.
When I search, what is it?
I don't know if I can tell you, but it's not MySQL. In that case, it's not MySQL.
Because I noticed a difference of performance there. Wow.
Yeah, we're working on that. I can just say that we're working also on that. Cool. Thank you very much.
Thank you very much. All right, so now we have 5 minutes or 10 minutes over. We have a 10 minutes break. If you want to use the bathroom, please grab a beer because I will not be presenting drinking alone. After all, we are in Ireland. So grab a beer. You can, it's up to you. I'm not going to tell you what you should do.
It's not MySQL. In that case, it's not MySQL.
Because I noticed a difference of performance there. Wow.
Yeah, we're working on that. I can just say that we're working also on that. Cool. Thank you very much.
Thank you very much. All right, so now we have 5 minutes or 10 minutes over. We have a 10 minutes break. If you want to use the bathroom, please grab a beer because I will not be presenting drinking alone. After all, we are in Ireland. So grab a beer. All right, everyone. I think everyone had time to go to the bathroom, grab a beer. So I will speed up because I can't handle this pizza smell here. So you'd be really hard to, yeah, 5 minutes. Yeah. You'd be really hard to keep myself concentrated here to speak. All right, at least I'm not the only one drinking. Yeah, I see just a couple. I was expecting more. Yeah, I was expecting more from the people. Like, yeah, come on, page, like free beer. All right. The 5 minutes, yeah, but I didn't start yet. This is not part of the presentation. All right. What? What has that? I don't know. OPC. I don't know. I think he's measuring how much I am drunk. It's as I get closer to it, it increases. All right. So I think most of, like, pretty much everyone that usually comes to the meetup knows me already, and they usually know that, like, or I talk about Chef, or I talk about Nginx, yeah. So this is completely different. I'm doing, like, I'm stepping out a little bit from what I usually do and talking. Let's talk a little bit more about knowing ourselves and how this relates to our job. And I was thinking, like, how the DevOps nomenclature started. Anyone have any idea? Because, like, this is a guess. Yeah. Yeah, but like I was saying, like how this started, because I feel that this was a sysadmin that had a marketing training, and he said, okay, I will call myself something different, but it's pretty much it. But like, oh, if I'm a sysadmin and I know how to code, I'm a DevOps. Wow. In the beginning, it was pretty much the definition, but this changed a lot over time. So DevOps, you need to know about business, you need to know about yourself, about the company, about processes, certifications, and a lot of other things that sometimes you don't want to know, but you need to. So, who am I? My name is Cassiano. I'm one of the organizers. I'm a senior staff engineer at Zendesk. Staff engineer, like they renamed it. I was a tech lead. I don't know why it's staff engineer. Don't ask me. So I have no clue. So you have here my blog and my Twitter handle in case you want to follow or check out. You only find out things about Nginx on my blog, but I have some nice stuff there. All right, so I will start by kicking out the elephant of the room, what I think about knowledge and experience. I've been working with this for more than 20 years, so I'm always going for experience. I don't care about knowledge. Knowledge, like, always proven me wrong. That's something when you put in production, then it breaks, and then you have like crazy nights working. And then I always go with experience, but it's my personal belief. So it's just because like 20 years working as DevOps, sysadmin, all of these buzzwords like made me in this grumpy old guy that I am now. But this presentation is not really about this. It's more about our love about technology. So, and get to know about more yourselves. But who would say, like, from everyone here, who works with bleeding edge technology? Like, yeah, but it's, man, if you compare the market, you see that if you use Apache and MySQL, it's bleeding edge technology if you look in the market, because you have people using COBOL and DB2 and mainframes yet. So, like, it's because internet changed this timeline of what is bleeding edge or not. So, so what is bleeding edge? Bleeding edge is usually the latest technology and involves a lot of experimentation. And by the definition from Wikipedia is that bleeding edge technology is a category of technology so new that they could have a high risk of being unreliable and lead adopters to incur great expense in order to make use of them. So, is that good? Well, it's not inherently good or bad. It depends. If you think that knowledge is better than experience or experimentation is better than maturity, it's not a problem at all. Like, we have places for all the technologies. Depends on what your team are doing, what your company are doing, what your customer expects. So we have places for all kinds of technology. No matter if it's Salt, no matter if it's Chef, no matter it's all like all different technologies, they get a job done. So, but does it mean that using bleeding edge is unreliable? No, it's not unreliable. It's just that you have a bigger risk of being unreliable because no one knows yet. No one is using it. Something new. So probably you'll be the one finding out that is unreliable when you go to scale, and then you need to look through the source code because no one else found it. You hit an unknown bug. So this is one of the prices that you pay when you use bleeding edge technology. So talking about reliability versus the bleeding edge, cutting edge. So bleeding edge doesn't mean unreliable, but bleeding edge means operational burden and increased risks. But again, this is not bad. It's just something that we need to know every time that we take a decision around which technology we will use. Like when someone comes with a project and you think, okay, I could use MySQL to do it. And then you think, you know what? I'm so tired of using MySQL. I will spin up a Cassandra here or something else, but you really don't need for that project. So all these things need to be taken into account if you want to be like really a DevOps and not just using your environment as a laboratory. So, but then it raises the question because everyone likes bleeding edge. You see that when I asked this, you see that when people that raised their hands, everyone was smiling. I use bleeding edge, and people that don't use was kind of, yeah, I still use old stuff. So like, but why we have this feeling, why we like, is because old is boring. And like, and it's so boring that sometimes we prefer to suffer the pain of running the bleeding edge in production then using the same bleeding, the same boring technology over and over and over and over. But why this happened? This is the question. It's like our brain is rigged for that. We human beings, we are rigged for that. And you don't need to trust me. I will show you an experiment, and I will have time to drink my beer, obviously. So I will show a 3 minutes video for you.
A landmark study at Harvard and Virginia universities found that students prefer to experience physical pain over 15 minutes of boredom. To demonstrate the surprising lengths people will go to avoid boredom, we brought in an unsuspecting subject for what he believes to be a focus group. We begin by introducing a set of stimuli, one of which is very unpleasant.
Oh, shit! What? Shocked the shit out of me. Touch it.
Oh, it did shock me.
No, it didn't. Did it really?
Yeah, it did. He doesn't like it.
That really shocked me.
Our fake focus test continues.
So, let's start with the shock button. Jameson, would you choose to experience this again?
I don't want to do that again.
Why wouldn't you?
Because it shocked me, and I still feel it going down my forearm.
Now it's time for Jameson's true test. The test of boredom.
You will be in the room for 30 minutes. Please remain in your chair. Feel free to re-experience the electric shock button, or not.
Okay. All right, the moment of truth. When the only two options are boredom or painful shock, which will our subject choose? He's not even looking at the button. It hasn't even been a minute yet, and already Jameson is restless. With nearly a half hour to go and no other stimulation in the room, the shock button is a tempting object to occupy Jameson's mind. Remember what Jameson said a few minutes ago?
I don't want to do that again.
But will he desire stimulation so strongly he just goes ahead and pushes that button? It took exactly 1 minute and 57 seconds of boredom for Jameson's mind to go from never again to, sure, I'll give myself an electric shock to relieve boredom. Sometimes stimulation, any stimulation, is perceived as better than none at all. Now this guy doesn't like being bored, but can he resist touching it a second time? We're social animals. Whether it's another human, or a volleyball, or an electric shock button, you'll make friends with whatever you need to. Jameson, I'm Michael. Thanks for coming in today. So tell me a little bit about what you've been up to here in this room.
I've been just sitting in this room with a button.
Yeah?
And despite saying I didn't want to press it again, I pressed it twice.
Why?
Oh, I was just bored in this room, I suppose. So,
Really?
Yeah.
Did that hurt?
Yes.
The hypothesis is that when left alone with a very negative stimulus, people will go ahead and re-experience it just because it's something to do.
I'm one of them.
All right. So, if we stop to look, this is not bad. This was what drove us out of the cave to look for things because, a lot of things outside can eat me. I'm not going to step outside of my cave. So it's not bad. It's what led us to evolution. It's what led us out of the cave. So this is not bad, but this is something that we need to be aware of, and we forget about this a lot of times when we take decisions. And the point is, every new technology that we put in production, that we do something, it goes from being something exciting to be something really boring really fast, because internet is like this. Things change overnight. Like today it's console and Terraform, tomorrow it's something else, and on things every single day. So we have all this information really easily available to us. So we get bored really fast now. But like, and this is not a problem because we are humans. Like, we like excitement and we hate what boring, like what should be. But what is the problem about this? But what about our customers? What are internal or external customers? The people that use your application. What they think about this? Like, they really don't care about what you are running. You can be running COBOL with DB2 as long as they open the website and it works, they will not say a word. Like, they don't care if it's Cassandra, if it's Redis. So all of these fancy names and fancy technology, we do this because of we need this, not because our customer needs. Obviously, sometimes it makes our life easier, give us a lot of, we can scale things out, but we need to think, okay, is this my primal mind trying to trick me, pushing something new to production, or is it really something that I need? So this is what we need to know. But let's say that we really want to use bleeding edge. So what we need to learn to be able to accept those risks and to be able to use bleeding edge. The first thing that we need to know is we need to be able to isolate the pains that we feel about bleeding edge. What I mean by that, our customers should not feel the pain. So I'm not putting bleeding edge in my principal path of the request of something in my company. I put in a place that if it fails, you not affect my customers. Or it's something that I have a secondary system in backup. Or like you always introduce until you gain maturity with that technology, and then you can move to the critical path of your application or solution. So, but how we do this? We need to do like, one thing that everyone does this running is like better proof of concepts. Proof of concepts is not just like, oh, I can install the Debian package on the server and it's working, the application is running, I can connect with Redis CLI. No, I need to know like how, when the hardware fails, when like the server goes down, when I need to restore a backup, when the disk crashes. I need to test all of this because this is the only way for me, because this is the price for me to use bleeding edge, because I need to figure this out myself, and I will not find someone that have this all written for me that I can use now. I need to be the one there like in the middle of the jungle opening the path because there is no one else went there. We need to learn how to do graceful degradation. So if this fails, like for example, I use Elasticsearch for my search. So let's say that I'm introducing Elasticsearch now, and for some reason Elasticsearch is not working. No problem. So let's do a failover and do a full text search on MySQL. Or let's mark that box on the application with red and say search under maintenance, instead of just failing the whole application and taking everything down just because search is not working. So we need to think about all of that when we use the bleeding edge. We need to have a lot more monitoring, a lot more metrics, because when things fail, and they will fail, it may not fail for a long time, but when it goes to scale, it fails. It's like, I never saw this happening in 20 years, different from that. We need to increase deadlines. What I say, like when you do a project that you say, okay, I'm introducing this bleeding edge technology on my project, so instead of taking a month, you take 3 months. Because you need your time to do your proof of concept, to do your degradation. So it's a cost in the project that the company needs to be aware of. Only promotes stable technology to your critical path. This is not because of you, it's because of your customer. And that's why you need to understand your customer needs. And especially like learn to identify all the hidden costs for everything that you use. Like this, for example, how I do backup. Or if this corrupts, how long it take for me to restore, or can data get corrupted? All of this is a cost in the product that if you put them, like you just use MySQL for everything. I know that doesn't work, it's not a reality, but I know that no matter what happens, you go somewhere, you find someone in the internet that had the same issue that you had. So you need to put these hidden costs into the project. And and why this is so important is because you need to implement all this graceful degradation. And basically, if you want to use bleeding edge technology, you have pretty much two options. Or you should learn to fail gracefully when something fails, when something breaks, not take the whole company down together with you, or we should stick with major technology if you don't want to have this risk. Because the main point is that failures will always happen, but doesn't mean that needs to be an incident. Doesn't need to have something that your customer saw. Like backend can fail and go back again, and no one sees this happening. This is not a problem. No one cares. This is part of like we have 5,000 servers, like almost 7,000 servers running Zendesk now. I saw like one guy doing a statistic that let's say that at least each server fails once per year. Like no matter if it's disk full, memory full, CPU like maximum CPU. So we have 7,000 things that will fail once a year. So it's more than one failure per day. So you need to be, failures will always happen, but this should not turn to an incident that infects our customer. And basically, it's like knowledge is knowing that tomato is a fruit, and experience is not putting in fruit salads. So basically, it's don't put tomato in your fruit salad. So there is no good or bad technology. It's the problem is like when we use technology in a bad way, when we affect our customers with bad technology choices, and this is what we should avoid. Thank you very much. Any questions? Thank you. Any questions? I don't, yeah, sure.
As people grow old, they need to be more stable because they have their life being affected their work, so they need to be more stable in their life. And bleeding edge can take all these risks. They will still be in a productive life. So how does it affect your life?
I'm not the right person to answer that because I don't have personal life. But yeah, my manager is here. Where is my manager? I don't know, like he left. My manager is no. I was on PTO because the HR forced me, and I was on Slack answering questions. So I'm not the right person, but this is like, let's say that this doesn't change if you have personal life or you don't like me. It's more like how many hours you have available to work. So let's say that for me to do a project takes 1 month. But if I use Bleeding Edge, you take 3 months because I need to do all the proof of concepts, monitoring, all the tests that I need to feel comfortable. But if it's someone that has life outside of the company, he has 8 hours per day. So you take 6 months instead of 3. So this is just a matter of time, and it's one of these hidden costs that you need to identify and put in your project. Because at least I saw this happening multiple times in multiple people that are working, even with me, that like someone comes with a project and you look and say, oh man, this is nice. I want to work with this. It's a really nice project. So you say, no, I can do it in a month, just because you want to grab that. But when you do that, you are putting a burden in all these hidden costs, because you not be able to do a real POC in 1 month and implement in master stage and put in production. So this is is our brain like, I'm bored with this technology, so I will grab this because it's something different, and I will shock myself in the button non-stop during 1 month to get it working. So this is really tricky, like this balance, how it works. But in the end, like pretty much everything in life, even like it's not money, it's time. Like no matter what we do, no matter, like no one is able to, not even the richest man in the world have 48 hours in a day, has 24 hours like us. So like it's, time is the most precious thing, is the most expensive thing we have. So we need to book this, control this, and have everything, but like deal with the time that we spend personally with our life, in even working, because I'm working here, so how I use these 8 hours a day that I have at Zendesk to get to, it's my time investment to get results back. So like, okay, maybe bleeding edge technology is not the best way. I use major technology to be able to use this. Or for this thing, like I will take a risk. But then what I do, I will go with Alberto, that is my manager, raise a flag and say, hey, we have a risk here because it's something that we never use it, we don't know, we never tested, but like the rest is failing. We don't have an option. So do we want to have another risk just to see if it works? So then we leave to business to take the decision. Any other question? Yeah. I regret so many things, but one that I regret, DRBD. DRBD. No, the DRBD is the block RAID 1 across network. It's like when it works, it's beautiful, but when it doesn't work, it's you want to go home, like buy a ticket to Mexico, change your name to Jose, and never just eat burritos and drink Corona and never show back in the company. Thank you very much. All right, so James, it's your turn. Thank you very much.
Yep. Speaking of pain, I had a live demo environment all set up, and it got blown away about 30 minutes ago. So I've quickly set another one up. Speaking of pain, so I've just quickly done that, and I hope it works. But right, I'll just start at the beginning. Hopefully this works. Right, I work for Tombola. We're a gambling company. Sort of like online games, similar to Sky Bets. The other big one is Beat Gaming. Now, we've been looking at SQL Server 2017 release candidate, and it's the first time they've actually put it on Linux. Just hands up, how many people have used Microsoft SQL Server? And how many are currently using it in production? Right, okay. Good show of hands there. Has anyone managed to, again, hands up, play with 2017 RC yet? Right, okay. The whole idea behind Microsoft marketing speak is to not so much bring it on Linux, but to allow developers and also to make it more cloud friendly. The best way to describe it is Windows is a black box, it's not open source, and also Microsoft SQL Server is not open source. The idea is that Microsoft SQL Server running on Linux basically removes the black box from the OS, and in theory, it allows Microsoft SQL Server to use all the features and all the software associated with Linux in Microsoft SQL Server and vice versa. Now, it doesn't always work like that, but this is just a generalized, I'd say I've spent about 40 hours configuring and setting these up in virtual machines, trying different things, trying completely wacky things and off the wall, see what happens.
By the way, just one point. I see that a lot of people is looking like, oh, my SQL Server and my Microsoft SQL, and I use it in my previous company. That we had a lot of servers, and it's by far the best Microsoft product is Microsoft SQL Server.
Yeah, I wouldn't call it well. It's half decent. Basically, we use it to store customer data, and basically, it's how our sites run. A side project was basically I help run Devops in Northeast, which is in England, and we kept on getting this question of, well, how do we use Microsoft SQL Server? We need some guidance and help on 2017, as well as us personally using it as ourselves. I should point out we run on AWS, so we use RDS instances of Microsoft SQL and also MySQL. and I'll talk about those when I go into it. But the big one for us at the moment is what we actually do with Microsoft SQL going forward. One of the big things here is I'm more of a sysadmin / DevOps. I'm not a DBA. So I'm primarily going to focus on what I see as a sysadmin and also as a DevOps enthusiast. Just a quick introduction. Why did they put this on Linux? And also the scenario of, well, pretty much what we're trying to solve with Microsoft SQL Server 2017. Obviously, it's not yet released. It's still release candidate. Then I have released RC2 recently, which basically my thoughts in metrics and diagnostics. Some of those bugs and problems have been fixed, but I'll just talk about those a bit later. And then, of course, a question and answer session. The install instructions for RC1 were a bit of a mess. It wasn't straightforward what you needed to do or accomplish when you actually installed Microsoft SQL Server. It's, again, meant to make Microsoft SQL run on Linux. It's meant to make it platform agnostic. In many ways, it does, but in some ways it doesn't. And again, I'll get to that later. It's meant to be used side by side by other Microsoft technologies, such as SharePoint Server. And it's also designed to be used under Windows 10 using the advanced sort of like Linux shell. So you're able to install it under there. But to be honest, I've never got that working, and it's something I'm currently talking to Microsoft about. It's more portable than running Windows. Now, I do say Docker-like, as in multi-tenanted. Basically, you can stand up an instance of Microsoft SQL Server very quickly. I say Docker-like because, again, I've not yet, 40 hours in, been able to get it running in Docker properly or to any degree of accuracy. Basically, when Microsoft SQL Server runs on Linux and also on Windows now, it runs what's called SQL-OS, which is sort of like a user mode operating system which manages everything within SQL Server. So basically, you've got the Linux kernel and then the Microsoft OS on top for Microsoft SQL Server. So it's not as straightforward as it's just a simple application. There's an entire wrapper there which is handling thread, I/O, accuracy of all the data, query, and basically it's just like one large container. It's like a black box container of an application. Again, it's meant to integrate, but to be honest, I've not had much success yet in TeamCity, Octopus Deploy, in getting it running under there. The idea is that basically instead of having like a pet server, like a Microsoft Server pet that would just constantly run, is to basically tear down or be able to tear down Microsoft SQL boxes and then rebuild them as part of an EC2 instance or Elastic Beanstalk. This is what we're trying to get to. It might seem a long way off, and to be honest, it's a little bit of hitting a brick wall, but this is where we want to get to, and obviously you're talking about pain, and to be honest, Microsoft heard what we're trying to do and basically said we're mad, just because they never thought of using it that way. Licensing-wise, apparently, obviously it would be cheaper without the Windows license attached, Windows Server. We don't yet know what the licensing cost would be for 2017 on Linux. I believe it might be the same as the Windows ones, but we're not sure yet. And for AWS specific, if you're running on like a EC2 instance, then running the full Windows OS on like a T2, tier 2, is pretty bulky. So taking out Windows should free up resources for the SQL Server. For 2016, Microsoft did something a bit miraculous in the fact that they made some servers available to the cheaper and free options, which they didn't before. So basically, from SP1, such as database snapshot, column store, partitioning, that was now suddenly all available to standard users, and also some free users as well in Express. Now, these do work under Linux, or at least some of them do. and some of them necessarily don't. But I'll get to that. At the moment, just to describe our setup, we've got AWS data in Ireland and Netherlands regions. I'm trying not to get political, but if we're hosting UK data inside of Europe, and yeah, and also European data inside the UK, what happens when this happens without without boring you to death. Data laws like the EU data protection regulation kicks in. What happens when the UK leaves? What happens to the UK Data Protection Act once we technically leave? Yeah, it's quite a big one. Some companies in the UK are a little bit worried about safe harbour agreements, just with obviously customer data. It's just madness. We still don't know what's happening. And the three key points that what we're trying to achieve is basically, without spending a lot of resources, being able to dynamically move this data in between either EU, UK, without causing downtime to customers. And also, obviously, we rely on sort of like data protection regulation and also a gambling commission. So we have to make that data available 24/7 should they need access in different countries. I'm speaking like Spain, Italy, and a few others as well. So basically, if the sort of government of Spain comes to us and says we need to know who's gambled on your site in the last 24 hours, we have to be able to tell them. If not, we face potential fines. Again, without affecting production, how we're going to do that with live data that's bouncing around in between two AWS environments. And basically, just to go in a bit more depth, it was covered under one of the last presentations, but basically between synchronous and asynchronous replication. One thing I did notice, and somebody from Northern Ireland did notice, I left Northern Ireland blue. Completely unintentional. But basically, the issue we've got is how can we quickly get about a terabyte of information over to a different region without relying on Microsoft SQL replication? Because if we use Microsoft replication, then basically we're sending data outside that region because we're transferring it over the internet. So we need to think about a way to do that, and to be honest, it's not a straightforward or easy answer, because we've already got the data there, and if we quickly need to move it, I'm sure you're aware, like, DevOps itself is not being reactive all the time. Sometimes you have to be proactive. You have to think about what's going to happen next. You've got to think about what if. You know, it's not just about maintaining the level of service, it's about redundancy. What happens if X happens? What happens if Y happens? And sometimes you've got to think ahead of where you want to be in like 6 months to a year. And sometimes in our case, it's like 5 years, 10 years. What happens if suddenly we lose all the data in one division? Just say we lose all the data in Ireland. What happens then? Do we have a failback? Do I have any way to recover the data if suddenly AWS just stops working one day? We log in, nothing works. Again, it's standard sort of like managerial speak for redundancy, but it's very difficult. Now, just to describe this, the master's in Ireland in this case, and we've got replication partners in the Netherlands and England. So what we want to try to do, we've got a hot standby there, and obviously that's synchronous. But of course, what's the problem with having a hot standby which is synchronous as opposed to asynchronous? Yeah.
Plus the network.
Yeah.
As slow as your slow node plus the network traffic.
Yeah, and that's sometimes difficult. Ireland's a lot faster in that regard. We did measure this earlier, and basically we found that the Ireland reason was actually faster in AWS than the Netherlands for some bizarre reason we can't quite explain. But
sorry.
Yeah. And of course, in England, we've just got a replication partner which is asynchronous in itself, but we can't really fail over to it. That's why it's not a S rather than an R. because obviously none of the data really lives there, and we've got no sort of like data reporting there or anything like that, so it would be very difficult to actually fail over to. Stage 1, and this is stage 2. So the idea was we'd break away the synchronous node and then push it there. Now, there's something, again, bad with doing that. Not only we're leaving region, but basically we're treating the server as a pet rather than cattle. Basically, we should be able to retire the SQL instance and terminate it without necessarily affecting the data. Again, you could think of like AWS file storage, Glacier, or anything like that, but realistically, in terms of data, for what we're transferring, we've got to basically be within regulation. We can't just dump it on a file store, leave it in AWS, and then transfer it later. It sadly doesn't work like that. So it's difficult for us to wrap our heads around how we're actually going to do this. And then, of course, Microsoft SQL 2017 came along, and we did actually think about how we would actually get that data out. And it'll require a little bit of explain, but I'll walk you through it, and hopefully you'll be able to understand the method in the madness. And believe me, it is madness, but I'll try to explain it the best I can. Basically, in the first stage, we stop replication to the replicated box in Ireland. So we'll take that out of the equation, and then we'll package this replica, just the data, which will obviously be on Linux, not Windows, and then async that data to a new replica, and then from there just carry out an asynchronous transfer in England. So that way we're bypassing the issue of just taking it out to AWS, because we're just packaging the data, and then from Ireland itself just transferring the data across. Which does satisfy requirements. If you get confused, just speak up, because to us it is madness as well, but that's the way we've got to work around data protection regulation. And basically from there, the replication partner in England will have all that data from Ireland, and because it's been done recently, in the space of a few hours, basically we can then make that node active. And stage 2 is basically this. And I've just explained what we've done there, but can you see what we're trying to accomplish? Just by a show of hands, how many can kind of understand it?
Run away from accidents.
Yeah. Again, this is a scenario where there's no straightforward answer, but it's one that crops up from time to time that if worst comes to the worst, the data protection does kick in, we'll lose the European Safe Harbour Agreement. It's up to us to try and figure out how to, again, problem solving, suffering the pain, and just trying to work around that. I'm not saying this is a perfect solution, far from it, but if you can understand the method and the madness, then so much the better. Basically what the plan is, instead of having everything is sort of one replicated node and asynchronous between the two. So this is a failure on our part when we first set this up. Whereas basically we had asynchronous to the Netherlands, and then from there, asynchronous to England, which basically you're going through two different replication partners, which slows down the transfer of data to England. So instead, after some jiggery pokery and resetting it up, the idea is we'll have that with two hot standby nodes, both in Ireland and Netherlands, and the central main core in England, which immediately resolves the problem, because we can just terminate these two here, and using availability zones, just spin up how many we like in England. So does that make sense to everyone? Yeah, okay, I'm seeing some nods ahead, so I'm going to go with that. Now, I just want to give you sort of an introduction to the SQL Server on Linux. Now, I hope this demo works, because I have, again, rebuilt the box. Eh? Yeah. But as you can see here, this is how they package it up on Linux. Basically, the Linux process is there, and this is all handled internally as sort of like a black box. Again, SQL PAL. To be honest, I still don't know what that does. It just manages the processes and threads. So basically all this is black box. We've just got Linux here, and obviously anything that's available to Linux should be available to SQL Server just as a standard application, obviously closed source binary. But that's the way we're trying to do it. So here we go. I hope this works. I hope this works. Now, basically, there's some code Microsoft has obviously written. Basically, when this first started, basically all we had was something like this, which was not really beneficial. Even though I'll give you a step by step, to me it wasn't really explaining what it done and basically what it was trying to achieve. It works better under PowerShell on Linux, but again, it's one of those things where it kind of expects PowerShell in order to get started and running. Lucky enough, they did add a secondary element to that, which was the unintended install sample, which puts it down to a nice file as opposed to just line by line. This is what I'm going to attempt to run and just hope it works. Dope. Yep. Hang on.
They save the shell script on Windows that
Yep, knew I forgot something. Hang on. I'll correct this.
So is desired state configuration involved in this at all? Like, is the Linux version like drastically different configured than the Windows version, or is it?
The initial setup and configuration is a bit different from normal, obviously, SQL because it's not using MSI. Most of it's command line driven and syntax driven in the config files. I would recommend everyone in the room sort of like try and experiment and play with it on the Linux side, just because that'll give you more an insight what they're trying to do. And from there, I'll basically just try to fix this. But the top and the bottom of it is it's Linux-like. It's what they've tried to interpret Linux as, but it's not quite right on Bash. Under PowerShell, it does work a lot better. Yeah.
Do you already recommend everyone still running all of this layer instead of running kind of seamless version?
Believe it or not, SQL is also on Windows now. It has been since 2016. It was under 2014 as well in 2012, but it wasn't to the extent it is now. So the idea is, do you remember Windows NT on, I think it was like Spark or something like that, whereby they ran Windows NT under a different environment. I can't remember. Yeah. Basically, it's sort of like that. They're trying to pre-package all the Windows functions and APIs and then have a translation layer in between, and that will allows it to run Linux. But it also does that on Windows as well. Tell you what, I'll just skip this. Right. D2Us. Everyone familiar with data transaction units? It's usually a way of measuring DB performance. Basically, one DTU equals a share of CPU, memory, I/O, and also transactions. So realistically, out of an AWS T2 instance, you get about 5 to 10 DTU, which is a measurement of performance. It's usually just used on Azure for SQL Azure. But again, it's not really 100% accurate on AWS because it depends on your CPU credits, who else is using the same box as you, any sort of shared resource you have as well. After doing some metrics, it's around the same performance on Windows as Linux. It's about the same. Basically, in Linux, I found unoptimized queries without indexes to be slightly slower. Obviously, that's due to some sort of translation or even the fact it's an RC release. It's not really ready for prime time yet. Again, opposite effect on Windows. It was more optimized on Windows because obviously it's more mature on Windows. It's not really mature on Linux yet. Performance per transaction, like when you start a new transaction and then roll back a transaction, it seems to be a bit faster under Linux. On larger databases, it sort of like averaged out, both were equal. Apart from some crashes and a few other issues we experienced. I found most software did not really care if SQL Server was run on Windows or Linux. The only exception was SharePoint Server 2016, which complained, saying it was the wrong key code and it couldn't read the ASCII text from the installer. We did try to obviously correct that in PowerShell, but sadly it just didn't take. It was just confused. And basically from there, obviously the PowerShell gets confused on Linux with SQL Server running. When you try to run the SQL commandlets, obviously they're open source and free. Under Linux, sometimes it does fail. It just doesn't run the command, just errors out. So the interpreter doesn't quite work yet. Some of the diagnostics continued and some of the things were noticed were these ones here. Occasionally replication on a SQL master from Windows to a Linux slave would just fail, just stop. The server itself wouldn't report that. It's only because we had the monitoring in place to record that did we actually notice it failed. So again, sometimes it would error out to the point it just wouldn't report it failed. Sometimes on a Linux master, the SQL server would stop responding. Again, that was under the 3.10 kernel. After upgrading to the 4 kernel, it worked. I believe that's been fixed under RC2, which they've released. And again, shell crashing out on SQL commandlet. My thoughts on it, it's a good start. Basically, the issue is it needs to be better at Bash. Like you run the SQL manager and from the command line in Bash and you don't get many options. It's like start, stop, query, verbose, version. In order to be truly Linux, it needs to be better at basically the command line tools. Basically, the idea is to sort of take away a large section of the complexities of running Microsoft SQL Server and just give the tools the developers need, such as local DB access. Again, if you're a developer, you just want a quick way of just having Microsoft SQL Server just there. You shouldn't need to worry about the setup and configuration or installing the right MSIs or the right tools. It should just be available to you. One of the issues for database partitioning is it gets confused on the file names. So if you type in C:\Windows, it sometimes confuses dev/dev, with basically you're writing to C dev instead of dev, which I couldn't really explain why that was happening. It feels a bit rough around the edges, but again, it's an RC2. But from there, the strange thing, which really boggled my mind, was the following. If you can all see that. Does anyone see any problems?
It's nice that they use like minor, major, exclamation mark, all the things that breaks Bash, depending on how you do. And also, like they send you with a password without putting a comment to tell you that you need to replace it.
It would be much better if that was, encapsulated somewhere or, put somewhere else. But again,
I wonder how many SQL servers you'll be installed on the internet with these passwords.
Yeah.
This is a nice project.
Yeah. Now I've got the technical stuff out of the way. Basically, what we're trying to resolve is moving that data from one AWS environment to another without sort of like transferring data via SQL Server replication. And what our idea is to pre-package the data files and the log files, and then transfer them from AWS Azure into our workspace, which is in the office in Dublin, and then basically then transfer it to the UK rather than between basically transferring it over the internet. Even if you use like a VPN, it's not allowed. So basically, we've got to find a way of getting that data out and then quickly transferring should data protection regulation kick in or kick out, as the case may be. Yeah, but that's what we're trying to resolve. If anyone's interested, here's some details of what we're doing. We're hiring, and if anyone's got any questions, I know I'm getting some confused looks, so fire away.
Because of Brexit.
Well, to be honest, it's something I've had to think about. Like, to be honest, I just looked over some of the documentation we had, and it was more of a case that we're not really prepared for this. And it's not a straightforward answer. It affects many companies. I mean, Tombola specifically, we can get away from some of it, obviously because we've got Tombola International, we've got Tombola UK. But it's something that's been raised a few times now in Devops Northeast, and basically I've done a talk on it because people were asking the questions, well, how do I transfer this if I can't use VPN, I can't get the data out this way, I can't get the data out that way, so how do I keep it within the EU, potentially at the flip of a switch? One day we could just wake up and say, right, we're outside the UK, or we're outside the EU. Okay, you've got to keep the data within the UK Data Protection Act, which stipulates UK data has to be obviously secured to a UK standard. So anything on UK citizens has to be covered by certain regulations on a certain standard different from the EU. And same likewise for EU citizens, we can't have EU citizen data sitting technically outside the EU. Yeah. Yeah, but that's my talk, and I hope you've enjoyed it as much as I've suffered through it. Basically, what we've had to do is, in the case of Netherlands, restore Italy data and some, I think, German data there, because that satisfies the German data regulations on top of the EU ones. So it's not like it's a 50-50 split of anything. We've got more data in one area than the other. And the replication works by still the EU it's going through. We've actually verified with. Yep. Basically, it's more of a case if it's going between two areas that's still in the EU and transferred within the EU, then it's fine. But if it's going outside the EU potentially, then we can't do it. So once the UK is outside the EU, we don't know what happens. It's a question where, at a flip of a switch, we have to transfer it. Just don't know when, because no one actually knows. So for us, it's like one day we could just wake up and just say, right, UK Data Protection Act that only applies, EU Data Protection Law doesn't. And in that case, we have to go, well, the Italy data has to be, but the UK data, obviously, we've got to move it to the UK. So it's primarily the UK citizens' data that needs to be moved, not the EU section. So even though it could be over multiple countries, multiple databases, we'll have to get the UK citizen data out as fast as we can. And that way, it's secure, if that makes sense. Yep. Yeah.
You also need to apply to going through the UK. I mean, like going through a router which something in UK. So
yeah.
Find the cable. Let's go from Ireland to France between avoiding UK. So, or can you go through like I send this I think that I'm going through some routers which cable
Yeah. Yeah, with AWS, they do give dedicated routes between different data centers. The issue is that the UK one, again, we don't know what happens because once the UK leaves, we don't know if that cable is connecting Netherlands to Ireland or if it's bypassing that entirely. Again, there's lots of unknowns. Yep. It's still. Yeah, it would still fall under our remit to make sure and manage the risk it might fall outside. So it's not a straightforward question of saying who's responsible because, yeah, yeah. Yeah, yeah, exactly. You've hit the nail on the head there. Basically, we're responsible for that separation of data. But obviously, companies have just decided that the UK is part of the EU, so they've mixed the data. And I'd rather not be in a position where I've got to separate out and manually go through each database, work out who's a UK citizen, who's a EU citizen, and then try to work out, well, where do I put them? Lucky enough, we don't work like that, and we've never worked like that. So we've got the UK site, we've got a Spain site, we've got an Italian site. You know.
Now that is like that you just dropped the seeds that I'm going down a rabbit hole thinking all the problems of this. Jesus, I
Yeah.
never realized about it. I was not even thinking about it like EU data locality. Now it's Jesus.
Yeah. At the moment, EU law still trumps UK law, which is very good because it adds stability because we know what the law is. But until that point of we suddenly outside the EU, we don't know what the law will be. Uh, um, again, yeah. 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 I will add before it's all doom and gloom that as DevOps, we have to plan and predict what will happen. We can't just say, oh, we'll leave it tomorrow, we'll leave it tomorrow. We've got to think about it now as opposed to later because once that kicks in, it's like, yeah, yeah, yeah.
So, you're going through a lot of work to like work around SQL replication issues.
Yeah.
Has there been invested? I mean, obviously it's a super big deal to like rewrite for different database backends.
Yeah.
Have you evaluated rewriting for different database backends?
Yes, we have to some degree, but to be honest, we're planning to revisit that. Just in the fact that, I mean, we did look at MariaDB for a lot of stuff, but it would require a lot of engineering work and time. At the moment, it's again proactive on our part and my part to look at some of the stuff, not all of it, because some of it is obviously just business as usual work, but some of it is us planning ahead. So when it does actually happen, we've got some sort of fallback because we don't want suddenly people in higher up authority than myself in the company suddenly going, well, what do I do? Suddenly, this apparently applies, and I want to be able to go, well, actually, if you look here, we've wrote the script, we've got this, we've got that, we've got this planned, and this is our tunnel, and this is our plan. So ideally, we want to be able to think ahead to the point that one day the boss might come in and just start panicking, or one of the higher ups and just say, the data protection officer, the compliance officer, suddenly he's just panicking, or, what do we do, what do we do? And we can go, well, actually, our plan's here. We've already worked on it, we've already got stuff in motion, we've already got approval, signs off, and that's what we want to try to do. But realistically, it's not as doom and gloom as it sounds, even though it's, a lot of work. It's just a matter that, again, under DevOps, the idea is you plan ahead, you think about what you're doing. It's cutting edge, so to speak. It is cutting edge. Would you agree? And that's the whole idea behind it. Tombola is different because we actually have like gambling laws we need to comply to as well. So that's more red tape. But for us, luckily, it's more of a case that we've already had things in motion to protect ourselves. But for other companies like smaller startups and SMEs, then it might be more difficult to separate that data. But again, I don't think any sort of reasonable government will go, you're 1 day out of date, slap on hand, here's a fine. I think it's more of a case that over time they will start clamping down. But for now, it's not exactly right. But it will actually happen. So.
Thank you very much.
There you go.
Thank you, James. Now we will have some pizza, some beers. If you can approach any of the speakers if you have any question, we will be around here. So thank you very much. Thanks for the presence again. I really appreciate it. And see you guys next time. And girls.
But for other companies like smaller startups and SMEs, then it might be more difficult to separate that data. But again, I don't think any sort of reasonable government will go.
Iubirea mea primește fericirea.